Alright, so in this video we're going to talk about the power rule. So let's look at the derivative of x squared, and then we'll look at the derivative of x cubed. Now we've done this before, I'm going to do it again in full detail. So the definition of the derivative is the limit as h goes to 0 of the difference quotient. So what we do is we plug in x plus h into our function. We plug x into our function, we take the difference and we divide by h. If you expand the numerator of this difference quotient, you're going to get x squared plus 2xh plus h squared minus x squared. If you cancel the x squareds and then divide the remaining terms by h, you'll get 2x plus h. And as h goes to 0, this goes to 2x. So now let's consider x cubed. So it's very similar. We're going to have this difference quotient with x plus h in the cube function, x in the cube function. We'll be taking the difference of those things and then dividing by h. We'll get x cubed on the top, x cubed plus 3x squared h plus 3xh squared plus h cubed. Then we'll have that minus x cubed again. And the x cubes cancel, and we divide the remaining terms by h. We'll get limit as h goes to 0, 3x squared plus 3xh plus h squared. And as h goes to 0, the last two terms there go to 0, and we're left with 3x squared. Okay, so we're seeing a pattern. We look carefully at these two examples. X squared becomes 2x, x cubed becomes 3x squared. Here's my pattern. We're going to call this the power rule. If we have x to the n, then its derivative is going to be n x to the n minus 1. So the n comes down, becomes a coefficient, and the power gets reduced by 1. Another way to write this is the derivative of x to the n is n times x to the n minus 1. And we read this is Leibniz notation. This is the derivative of whatever's in the parentheses. Okay, so let's prove this. We've done a couple examples, so we have an idea of how the proof will go. So we're going to have x to the n. We're going to take the derivative by taking the limit as h goes to 0 of x plus h to the n minus x to the n all over h. We want to expand this x plus h to the n for general n, so we need a formula for any n. And the binomial theorem tells us what this is. So the binomial theorem says if we take this binomial to the power n and we expand it out, we'll get x to the n plus n times x to the n minus 1 times h plus n times n minus 1 over 2 x to the n minus 2 times h squared, and so on. The subsequent terms get one less power of x and one more power of h, on and so forth. The coefficients change in kind of funny ways, but we don't really care about that, and you'll see why in a little bit. And then the very last term will be h to the n. So we'll go all the way down till we've eliminated all the x powers, and we've raised the h to the power n. Okay, so that's x plus h to the n. Again, that's the binomial theorem. Binomial theorem. And then we subtract x to the n, and we divide by h. All right, so the x to the n's are going to go away. We'll be left with n times x to the n minus 1 times h. And then we have n times n minus 1 over 2, x to the n minus 2, h squared, and all the way to h to the n. Now all those terms have h in them, so we can divide everything by h. We'll be left with n x to the n minus 1 plus n minus 1 over 2 x to the n minus 2 times h, and the last term will be h to the n minus 1. Now note, all these terms over here on the right, all the terms except for the first term have h in them. All terms have h. So when we take h to 0, they're all going to go to 0. They're all going to go to 0. And so we'll be left with n x to the n minus 1, which is exactly what the power rule says. Okay, so that concludes our proof. All right, let's do an example. Okay, so we'll call this example 1. And we're going to differentiate or take the derivative of several power functions. We'll start with x to the 5th. Then we'll look at x to the 3/2. Then 1 over x. And last but not least, square root of x. Okay, so the derivative of x to the 5th, by the power rule, we're going to bring the 5 down, and we're going to subtract 1 from 5. We get 5x to the 4th. Pretty straightforward. Derivative of x to the 3/2. Now we haven't looked at a fractional power before, but the power rule does apply here. We're going to bring the 3/2 down, and we're going to subtract 1 from the 3/2. And that will give us 3/2 x to the 1/2. All right, derivative of 1 over x. First thing we're going to do is we're going to write 1 over x as x to a power. 1 over x can be written as x to the negative 1. And then we can do the power rule. The negative 1 comes down, and then we subtract 1 from negative 1. And that's our new power. And that'll give us negative 1 x to the negative 2, which if you don't like negative exponents, which I typically don't like, you could rewrite as negative 1 over x squared. And then the last one, square root of x, we rewrite as a fractional power. Square root is the same as x to the 1/2. And then we use the power rule, so we'll get positive 1/2, x to the 1/2 minus 1, which is 1/2 x to the negative 1/2, which you could rewrite as 1 over 2x to the 1/2, or you could write as 1 over 2 square root of x. These are both acceptable. Okay, so the power rule applies to lots of different functions. I hope you found this video useful.